For agents, it's more about who authorized them, what intent was declared, and then what actually happened. This is the attribution when humans and machines collaborate.
Hello, everyone, and welcome to our next session. Today, I'm joined by Gaurav Singodia, who is the Senior Manager of Cloud DevOps at Snowflake. Prior to Snowflake, he was with NVIDIA, NetApp, and Dell EMC. With that, I'm going to go ahead and hand it off to Gaurav. If you guys have any questions, please add them into the Q&A, and we'll get to them towards the end of the session. Thank you.
Thanks, Ashur. Hi, everyone. Myself, Gaurav. Welcome to NHIcon. I hope everyone is enjoying all the sessions so far. And I'm glad to be here to speak with esteemed speakers. It's glad to exchange notes and the learnings from everyone in the industry, trying to exchange the NHI problems, statements, and then the solutions and what we can do and how the future looks like. So with that said, share my slides. Okay, I hope you're seeing my slides. All right. So governing the ghost in the machine, identity and security for agentic AI. So we have been training for years machines how to think. I think we are at a moment where machines have started to act, and as the software gains agency, the question becomes not what it can do, but more around who owns it and who controls it. And that is pretty much the premises of this topic today about that ghost in the machines and then what the governance around looks like. My presentation, consider it as me exchanging notes with all of you over here in terms of some of the real world problems we are trying to solve at Snowflake with NHI. I would like to keep it as practical as I can and less theoretical, and work for next few minutes and then also walk you guys through some of the live examples on what we are up to. So the problem statement that I'm going to discuss here today is, so agentic AI, by now I'm sure you have heard from Phil, David, everyone. It's not about what is it really trying to do, right? It's not about model intelligence, it's about executions. Agents are no longer advisory. They log into systems, they trigger pipelines, they call APIs directly. And at any moment, an API can take action. Identity becomes part of this production control plane. As engineers, why should we care? Well, we are used to bugs causing incidents. With agents, the identity misconfiguration becomes the fastest failure mode. And then even a single over permissioned agent can actually propagate mistakes at machine speed. So there is this a distinction between scripts versus agents, where scripts do exactly what you tell them, and then agents on the other side decide how to achieve a goal using tools. Now, this flexibility is powerful, and this is where all the static security assumptions that we have been used to, they completely break here. So, how do we address this, right? Now, when it comes to agentic life cycle, agents don't stay the same, right? What you see on the screen is simple workflow. There could be a couple of more permutations and combinations around it, but for simplicity, what I'm trying to say over here is that agents start as prototypes. They gain some tools over time, more and more autonomy, and there is more and more trust that keeps adding on as the autonomy increases. The danger is that these permissions only grow and they keep growing. And during this life cycle, at some point, an identity drift is born. Now, identity drift is real. So, drift happens when the permissions of these agents reflect history and not its actual intent, because they started as prototype, and then as they gained more autonomy, that is where the permissions are still reflecting the history and the intent might be changing with time. So more and more prompt changes, more and more addition of new tools, more and more model upgrades silently widen your blast radius. And this is where the life cycle of an agent is something which we should always be focused about, because the intent and the behavior could drift over a period of time. So this one, I think most of the audience should be familiar with, where IAM has been around for a long time. It's nothing new. On the left side, what you see is a traditional IAM model. There are some roles, some stable roles that IAM assumes. There are long-lived services, and then there is some predictable behavior based on the policies that you attach to that role. And then we are pretty much used to it across any cloud service provider, across any tech stack. On the right side, when we are talking about agents, we are talking about dynamic identities, short-lived functions, and we also talk about something ephemeral. So, in short, agents violate all three. Now, if your IAM model depends on all three, then this is where the IAM model will fail. So, this is a problem that we have, and how we have actually tried to solve. And one of the examples I want to talk in my next slide is with classic example around non-human identity for workloads. Now, in this, what you see is pretty much, you can think of any CI/CD pipeline. In my example, it's GitLab. And so GitLab, any CI/CD platform, your any pipeline in that CI/CD platform contains secrets, and those secrets can be written in blogs, can be committed to code repositories, can be poisoned through code to steal secrets. When we want to move away from this, like, while this functionality is essential for you to run your pipeline, for your systems to talk to each other, at the same time, there is a growing risk in terms of more and more workloads. On the right, what you are seeing, whether it's Jira or Beyond Identity, Git Guardian, all the systems that your CI/CD pipeline talks to, there is an unknown workload posture. And then in this process, there could be some privileged credentials that were touched by multiple humans, posing a security concern. So in our world, we used Ambit, which supports, by the way, both two-legged OAuth and three-legged OAuth for accessing short tokens. And then what we tried to do with Ambit is that we we chose the API approach, where the full control of these pipelines was something that we wanted to control using Ambit. So what Ambit does by sitting in between is brokering the identities between your GitLab slash CI/CD pipeline on one side, and a large range of workloads on the other side. So where Ambit helps for us is this trust relationship between the Ambit cloud and GitLab instance. And what we saw, and we have been seeing, that through this API, Ambit basically intercepts the request, requesting the service account token that identifies, oh, this is the GitLab instance. Let me send it to Ambit Cloud, have some cryptographically attested identity with it, and then exchange the metadata without adding any kind of secret or credential to the workload itself. All this is driven by a policy, which is more about an additional layer on the conditional access that this metadata exchange information is taking place. So whether it's this communication or any other future communication between this CI/CD pipeline and the workloads is normal, and everything gets logged as a transaction, as a metadata transaction of every request. So how does it help? Well, it eliminates the need to see or store any credentials, and provides much stronger security posture for us. So this is one example, that in case of workloads, how non-human identity actually helps us in our day-to-day operations. At the same time, there is another example that I want to use for my agentic workflows. So if taking a pause, when I talk about NHI, there is NHI for workloads, there is NHI for agents, right? Agentic AI agents, you are giving power, trying to do some actions over it. So with that, on the agentic side, right, what you are seeing is you want agents to operate safely outside your cluster. There are three parts primarily in this workflow. One is the identity flow, one is the 𝗞𝗲𝗍, which is in practice, and then one is the OIDC. Identity flow pretty much is the starting point. That's the backbone. Point here is the agent never holds secrets, and that identity is issued at runtime. 𝗞𝗍𝗍, workload identity without secrets. So it basically gives each agent a cryptographic identity, and then the rotation is automatic, so there is nothing to leak. And then OIDC is more on the claims based trust, right? That's where you let agents authenticate across trust boundaries, across cloud providers, across different SaaS tools. So over here, right, I have a little demo. Before I play a demo, I want to just emphasize on why and how we are moving from systems that execute instructions to systems that pursue goals. So identity models that we build for scripts and services, they don't hold up once the behavior becomes non-deterministic. So point is, and that's one of the things I'm going to again reiterate in after a couple of slices, what you would see, agents have blended identities. It's never acting alone. It's always acting on behalf of a human, a team, or a policy, and using infrastructure it doesn't even own. So that blended identity at conceptual layer is basically multiple layers of identity that are evaluated together. There is a human identity, there is an agent. Human identity means who initiated, there is an agent identity on what is acting, and then there is a runtime identity where slash how it's running. So if I were to expand on it a bit, a human identity, pretty much who approved, prompted, delegated, is where it begins with. And then the agent identity is the purpose, the logical agent, which knows what the purpose is, what the role is. And then workload identity is the short-lived cloud workload identity, spiffy, what I was talking about. So no single token is trusted. And this trust is the intersection between all these three. So from a architectural pattern, agents require about the authorization intent and what actually happened. So a human, when they declare their intent, the agent needs to accept it as a task. And then the identity token should actually take care of the delegation, the intent, the role, the scope, and then the action that locks against that tuple. So what does a zero trust means for non-deterministic actors here, right? So when I say zero trust, it does not mean never trust the agent. I mean, that's impossible. Then I don't think we would be able to take any action. But I think what we mean by zero trust is we don't trust the future behavior. So from a architecture point of view, the shift is from authenticating once and authorizing broadly to continuously authenticate and authorize every action in this journey. So in simple terms, it's a loop, a zero trust loop for every agents out there. And every action that gets requested, there is a policy behind that evaluates this blended identity, the context, any kind of risk signals. And then we see the just in time access model about what access got granted, the behavior, monitoring of that behavior. And then at the same time, that access also should be revoked, it should be expired. That's the JIT model. So the default state for any agent is no access, even mid task. Like that's like the default state or the criteria to start with. So with intent, purpose, and runtime context, there is a continuous action that needs to be evaluated. I want to show a quick demo about an SRE agent that is a real world example, which actually talks about or what I just said. So there is blended identity. Let me see if I can play this video here. Sometime I'm trying to do it fast. So I had to play that video fast, but what I'm trying to say through that video was today we have an on call engineer who authorizes an auto remediation. That's one identity. There is an agent, we call it SRE remediator, that's basically acting on behalf of what that remediation looks like. And there is a runtime Kubernetes workload identity. So what we have in that video was just-in-time access. The agent had just-in-time access to logs, metrics, and deployment APIs. And then access gets revoked immediately after a task is performed, what an SRE agent would do. The example, if it was not visible clearly, was trying to increase the infrastructure component of our Kubernetes cluster in real time without actually waking up an engineer nighttime just based on what it saw in the logs. And at every point of time, if there is a deviation in the behavior, the access is cut mid execution and then an alert gets triggered. So that was one real example that I wanted to show. One pager that if I can have everyone take away from this would be the agent's runtime don't hold secrets. The identity is issued dynamically, and then access is always scoped, and every action is continuously observable and revocable. This architecture is cloud neutral, and then it should clearly map into any of the systems you are used to. So from a NHI perspective and at that scale, identity is not just authentication, it's more about governance. And these autonomous systems, as you give more power, they require continuous control and not static trust. And with that, I this just final thought. The risk is agents with forgotten permissions, and that's what I was talking about when we talk about widening the blast radius with time as you give more and more autonomy, and not just primarily because the agents got more intelligent. With that said, I want to leave some time for Q&A.
All right. Thank you, Gaurav. Yeah, let's get to some of these questions. So one of the questions we had was about Spiffy and Spire and how that's being used, and how you're doing like attestation of a blended identity.
Yeah, sure. So it's actually a good question and it's very common. So when I was talking about identity, blended identity, the agent identity sits between human identity and the workload identity. And then once there is a role and purpose that the agent identity is defined, the attribution problem is usually what these agents really want to require, what they want. Like the traditional logs usually would give you who logged in, but for agents it's more about who authorized them, who authorized this agent, what intent was declared, and then what actually happened. So this is the attribution when humans and machines collaborate, and that's where the blended identity, like spiffy, when I talk about the cloud workload identity, this is where the humans and machine collaboration between the short-lived and environment bound workload identity provides that blending. That's the trust that comes between the intersection.
Okay. And related, when you showed that the agent flow, one of the questions that came up was, will the agent be given a SVID or will it get a JOT?
Will the agent be given a what?
SVID, the Spiffy identifier, or just a JOT? Like you in the diagram you had like one was going to the other one and then it was circling back.
Yeah, no, it would just be jar. It would just circle back to that. Now, one thing I want to kind of mention in that life cycle process, there could be couple of iterations, right? When we talk about the blended identity or the conceptual layer, because you the token, right? End of the day, when we are talking about any architecture of a token, and there is an intent during the flow, the token is doing the delegation part, the intent part, and then also the whatever the role and scope it has. So every action is against something, against a row, against a tuple. So the goal is to preserve the chain of intent and not to blame the agent. So
Well, thank you, Gaurav. We're at the end of the session. If you guys have other questions or you need access to the video Gaurav was showing, please see me at the virtual booth and I'll get you as much info as I can. Again, Gaurav, thank you so much. We'll
thank you
see you
very much.
next time.
Thank you very much.
Take care.